All right, so today we'll go over the homework. We're gonna revisit that last example that we saw yesterday where we encountered a little issue. I worked it out, and then we're going to be learning uh, something called Heron's formula, where we are able to find the area a different way, an interesting way. So we'll have two new methods of finding the area of a triangle without using our classic 1/2 base times height. All right, so for both of these, you were supposed to use the law of cosines to find the missing side. So for the first one, we're supposed to find side A. So that tells us we're going to use the equation a squared equals b squared plus c squared minus 2bc times the cosine of a. All right, so you can label it if you want. Doesn't really matter. Nope, that's wrong. Your C is 30, your B is 21, and then your angle A is 123 degrees. So we're going to have A squared equals 21 squared plus 30 squared minus 2 times 21 times 30 times this sine, oops, not sine, times the cosine of 123 degrees. All right, so you can plug all that in. Again, just be careful whatever you find isn't your final answer. So 21 squared plus 30 squared minus 2 times 21 times 30 times the cosine of 123. So here I'm going to get a squared is about 2027, I'll say 0.25. But again, remember, the more decimal points you use, the better. And then we take the square root, and we get about 45. Okay, I'm going to put these squiggles here, which means approximately. So A is approximately 45. And that's our final answer. You do get, I think, yeah, from the calculator, I get 45.02493995. So, maybe I'll put 45.02, but 45 would be good enough there. Because usually we round to one decimal place, but that's up to you. Any questions about the first one?
No.
Right. And the second one, similar process. We're just looking for a different side. Now I'm looking for side C. So my equation, I have c squared equals a squared plus b squared minus 2ab cosine c. Now, one thing I do want to say, too, if by chance you mix these twos up, right, so if I accidentally called this side b and this side a, although, I might mark it down and note, say, oh, be careful. In this case, it doesn't really matter because here you're squaring them and adding them. So, it could be in any order here. And here with this multiplication, it could also be in any order. So the order doesn't matter, right? Or even if you wrote the equation differently, if you have c squared equals b squared plus a squared minus 2ba, that's all right. Okay, so there is a little room for error here. You just, just not something crazy. So I have c squared equals 22 squared plus 20 squared minus 2 times 22 times 20 times the cosine of my angle here. I'm running out of room. Move over. The cosine of 95 degrees. The right side, plugging all that in, 22 squared plus 20 squared minus 2 times 22 times 20 times the cosine of 95. I get c squared is equal to 960.7. And we take the square root. And I get c is equal to so I get my specific precise answer. I get 30.995, but you can tell me 31. That would be okay as well. I don't know what I'm doing here. What did I hit? Oh, cool. That's neat. Okay, any questions about that? All right, then to quickly revisit what we talked about yesterday. All right, we had our triangle, and we didn't have any of the angles. We were just given the sides. So the problem we encountered yesterday is that we solved for angle A first, and then that gave us a weird angle B. The issue is angle B would be obtuse. When we're dealing with that, yesterday what we did was to find angle B, we used the law of sines. That poses a problem because the way our sine function behaves. When I take the sine of an obtuse angle, weird things happen because now I'm on the back side of the sine curve, right? So it starts coming back down. So I'm going to leave us with a hint to find the angle opposite of the largest side first. So here, the first thing that we would find is angle B. So we would have a squared plus c squared minus b squared over 2ac. That's a c. So that would give me the cosine of b is equal to, let me just label real quick, b, c, a. So I'd have 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. So solving this, 8 squared plus 14 squared minus 19 squared is actually going to get us negative 101. And then 2 times 8 times 14 gives us 224. So angle B is going to be the inverse cosine of that fraction. And good. And yeah. So now we get angle B is equal to 116.8 degrees. And that's where we were encountering our problem yesterday. All right, I think yesterday we found A first, and then we used that to find B, but it wasn't giving a B as an obtuse angle. Okay, it was giving us a B that was an acute angle, and that's again because we used the law of sines. So now that I have this obtuse angle, then I can use the law of sines to find either A or B. I'm sorry, A or C. So let's just do that real quick, just because we didn't get a chance to finish yesterday. Let me move this down out of the way. All right, so I can set up then sine of C over C equals sine of B over B. So I get sine of C is equal to 14 times the sine of 116.8 degrees all over 19. So calculating that. Taking the inverse sine, I get angle C is, I forgot what it was, 41.1. And I think we might have found that yesterday. I kind of remember that number. And then our last angle A, I could just do normal angle addition. So I would add 116.8 and 41.1. Subtract that from 180. And I get angle A is equal to 22.1. And we solve the triangle there. All right. So yeah. So again, if you're given a situation where you're just given the sides and you want to find the angles, okay, find that largest angle first, and then work your way back from there. Okay. So I think, yeah. So this is going to be one of the last equations that we're going to use. And actually, this one is interesting because it doesn't involve any trig. Okay, we use the area of a triangle and trigonometry to set it up. And I'm not going to bore you with the whole proof and everything, and I'll just give you the formula. So this is oh, I hate how it always makes a circle. I'm not trying to make a circle. Okay, so this is interesting. Here I can find the area of any triangle if all I know is the side lengths using Heron's formula. Now, Heron's formula is the area is the square root of this number s here. And there's a name for that. They don't tell me here, though. I thought they told me. I think they call S, if I'm correct. S is called the semi-perimeter. And, it's kind of self-explanatory. The perimeter, we add up all the sides. And we divide by 2. So that would be the semi part. So it's kind of like finding the average, but instead of dividing by 3, we divide by 2. So we come up with this number s, and then it's just pretty straightforward. It's the square root of s times s minus a times s minus b times s minus c. All right, so you're multiplying those four numbers, and then you're taking the square root. And that is Heron's area formula. Okay, I'm going to move it, but I'm trying to move it so. Yeah, that's good. So, yeah, we got 10 minutes. Let's look at an example. Okay, so we're going to find the area of a triangle with side lengths. A is 43, B is 53, and C is 72. So we got some large numbers here, so we will probably end up with a fairly large area, so don't get thrown off by that. So the first thing we want to calculate is S. Okay, we can't do anything with the area formula without S. So I'm going to add my side lengths up, and I'm going to divide by 2. All right, be careful if you're punching it into the calculator all at once. Make sure you put parentheses around the numerator, or you can do it in 2 steps. You can do 43 plus 53 plus 72, press enter, and then find that that's 168 divided by 2. So S is 84. So then we're going to set it up where we subtract all of our sides from 84. All right, so I have my area is equal to the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. That's a 4. That looks like a 9. Let me change that. All right, so PEMDAS, order of operations, we do the parentheses first. All right, well, that's going to stay 84 for now. 84 minus 43 is 41. 84 minus 53 is 31. And then 84 minus 72, 12. Right, I think. Yeah, 12. Right, so you can type it all in at once, but I'm going to do it step by step. So 84 times 41 times 31 times 12. So usually, yeah, if you're dealing with large numbers, this number is going to be pretty big. The square root of 1,281,168. And you take the square root of that. And we get our area is 1,131.9. And I didn't give you units, so we'll just say units squared. All right. And that's Heron's formula. Any questions there? All right. So we learned a lot. Okay, especially just within these last 2 sections with the law of sines and law of cosines. Right, and then we got all of our identity functions where I gave you the cheat sheet. Right, so your Pythagorean identities, your quotient identities, and then you get real fancy with the double angle formulas and the half angle formulas. Okay, so just, I know it's a lot, so just take it step by step. It's once you get kind of past the overload of information, it's fairly simple. So the last thing I'm going to leave you off with is just a quick recap of the different ways we find the area of a triangle. First, we have our normal formula. Right, a triangle is half of a rectangle, so we find the area of the rectangle and we divide by 2, 1/2 the base times height. Then we have the oblique triangle, where we have the area is 1/2 AC sine of B, or 1/2 AB sine of C, or 1/2 let's say BC sine of A. And then we just came up with Heron's. All right, so with trigonometry, that kind of really expands our knowledge about just triangles in general, okay? But, clearly we can see here, because we have 3 different ways to represent the area of a triangle. Okay, so although we are done with the formulas of trigonometry, okay, unfortunately we still got a little bit of trig to deal with. Yeah, there's a few more topics with trig. And we're almost. There's so much in this book that I want to teach that's not in the curriculum, and that sucks. So we'll see. Maybe we'll get through the last part of the units, and then I'll be free to teach what I want. We'll see. Hopefully. All right, guys. Tonight I'm going to give you a quick example using Heron's formula. All right, I want you to practice using that quickly. Just get used to finding the semi-perimeter and then using it for that. And we'll go over that tomorrow, and we'll move on to something called vectors. And that's a little more on the physics side. All right, guys, have a good day, and I'll see everybody tomorrow.